Okay, today we're going to be looking at tangents, and we have two tangents here. We have AB as a tangent and AC. I swear to God it's a C. I know that looks pretty bad. So AB, AC are both tangents, and they're drawn to a common point. That point is A. Our goal is to prove that AB is congruent to AC. So we want to prove that this is the same length as this. And it's not that hard knowing the stuff we know. So first off, we definitely know that AO is congruent to AO by the reflexive property. Those have to be congruent to each other. Likewise, we know that BO, body odor, is congruent to OC, that show from Fox from the early 2000s. Maybe not. All right, but either way, we know that these two are congruent to each other because all radii in a circle have to be congruent. So if we're looking at these two triangles, we're like, okay, well, pretty close. We almost got it all. But we're missing something. We have two sides. We don't necessarily know these things. But there's one thing that we went over in a do now. That is, if you have a radius drawn to a tangent, a radius drawn to a tangent is always perpendicular. Super important. Radius drawn to a tangent, always perpendicular. Every single time. Radius to a tangent is perpendicular. So that would then mean that these two triangles are congruent. By angle side side, no, go to the dean, you can't say that word. Can't be angle side side, it is a right triangle, that's a hypotenuse, and a leg. These two triangles are congruent by hypotenuse leg. And finally, if we know that the two triangles are congruent, then by CPCTC, corresponding parts of congruent triangles are congruent, we know that AC and AB are congruent. So the thing to take away from this is if you have two tangents drawn to a common point, those two tangents are going to be congruent to each other. Super important. So like I said, two tangents drawn from a common point are always congruent. And they like to ask questions with this. They like to ask them usually like they put a shape like this, and they say, find the perimeter of this trapezoid or whatever, this quadrilateral. Maybe it's not a trapezoid. I don't know. I'd have to look into it a little more deeply. But the easy way to do that is like they'll give you enough information that if you can say that, all right, TR is the same as TH, HO is the same as OZ, ZE is the same as PE, and then PA is congruent to AR. Like all of these little things like that and that have to be congruent, and that have to be congruent. So if you add them all up, you could get the perimeter of that.